Hello everyone, in this recording we'll introduce time series visualization. We'll start with some of the theoretical aspects and then we'll look at a few basic kinds of plots. First, there are actually a lot more subtleties associated with visualizing time series than might be obvious at first, right? Some of the aspects that you have to consider. Is it one or multiple time series? Is time recorded in a qualitative way or quantitative way? What are the kinds of other measurements that are measured at each time point? What is the temporal frequency, and is it regularly measured? And then do you expect any kind of strong cyclic, seasonal, maybe large trends, kinds of patterns, right? So we use the same word to actually refer to many different kinds of problems. Time series visualization can be leading to many different kinds of plots depending on the properties of the data. The second thing to consider, what kinds of questions do you think people really care about? Right? And there's actually a lot of variation in questions. So first, the most obvious kinds of questions are identification and localization. So basically, if you think of the usual kind of line plot visualization for a time series, identification is fix some time point, what is the value of the series? Localization is fix some y value, fix some value of that series, at what x's do the series achieve that y value? If that were all, there wouldn't be that much complexity in time series visualization, but there are actually quite a few other kinds of complexities, especially when you have many different variables over time, or many different time series of the same variable across many different units. In this case, you often want to compare patterns. It's not enough to just look up values for a single series. You want to say, do these two states have similar trends? Or these two measurements I've gathered over time, is one influencing the other? Right? These are patterns that only become visible when you zoom out and you start comparing multiple series against each other. So if you went through the reading, you would have seen this diagram. And so this is an example of trying to decompose all the different kinds of visualization problems that you might encounter whenever working with time series. Right? It's not just look up x, look up y. There's a lot more subtlety. Okay, so that's some of the background theory. How do you actually make some of these kinds of visualizations, right? Probably the most common way to visualize time series data is to use a line plot. The reason it's so effective is because since it's encoding the value using a y position, it really easily shows any kind of slope and change information. Right. So here's the data set. It's the trade and Canadian lynx pelts. We just use a geom line. Here I've used it so that it doesn't have any kind of additional gap around x. So yeah, you immediately see these kind of large peaks and these kind of smaller peaks, and you also see the overall seasonal pattern. Okay, so now if you wanted to kind of really highlight volume, like the trade volume, it might make sense to use an area plot instead. Right? These are all these numbers have to be larger than 0. So instead of just thinking about it as a line changing over time, it might be useful to think about the overall amounts. And in that case, you can use a geometry. Okay. Now, if you have a larger collection of time series, things get a little bit more complicated. Right? So here I'm getting a data set that's total amount of tourism to different states in Australia, measured every couple months. You want to start saying things like, are there any large trends? Is there any important seasonality? Which regions are more popular than others? Okay, so I'm again using geom line. Now I'm coloring it by region. All this other manipulation. First, I'm just excluding business travel. I'm only looking at tourism. And here I'm getting the totals for every region. I'll be using that later on, but for now, I don't need it. Okay, and then if you just encoded the region by color, you get something like this, which is essentially unreadable, right? So before talking about how to actually fix up this plot, I wanted to highlight that there's one kind of common problem that you might encounter whenever you try to visualize multiple time series together. If I had not used color equals region, if I had just done quarter and trips, I would have gotten a very strange time series plot, something like this. Right? What's going on is geom_line is thinking that all these series actually belong to one series, and that it needs to have every single state at the same time point. So it's kind of connecting them all vertically, and you're not able to see any kind of single state level line. Right? If you wanted to not use color, but still make the colors, or still make the different groups visible, you would use this group equals region argument. Then it knows that, okay, this one state should be tracked over time. I'm going to have that one line over time. That said, this is still kind of an unreadable plot. So how to improve this? One is to use faceting, right? So here I've faceted by region, and I've sorted them from the most to the least number of trips. So you can see there's kind of some clear seasonality, there's some trend for Melbourne, maybe there's a little bit less seasonality in some of these series. Right? Maybe there's like a small trend over here for Southwest. Okay, this is much more readable. Right? We've separated everything out. The downside is this takes up a lot of space. Right? If you had any more counties or any more regions than this, I'm not sure you would be able to facet everything out and still be able to see it in a small enough space. A more compact approach is to use a heat map. Right? So this is the same kind of information, but now each row is one region. And I'm using color to encode the total number of tourists. You still sort of see the seasonality by the kind of periodicity in the colors. You can maybe even tell the trend for some of them. Right? But this is also not a great visualization because our eyes are they have a lot more trouble comparing color relative to comparing slopes and locations on Y position. Right? Just so you see how this is being made, I'm using geom_tile to create the heat map. This is X and Y. I'm telling it every tile I want you to be filled in by the amount of the trips. If I hadn't used color here, then you would have a thin gray box around each one of these little tiles. I like the boundary of that box to also be the same color as the inside, so that it looks a little bit more kind of continuous color. So that's why I've used fill and call to be the same variable here. Okay, and this is just making it so that I don't have any additional gap around my rectangle, so that there's a clear border. Okay, so more compact. The downside is you no longer can compare the nice differentials. In the next notes, we'll see some ways around this. There are actually some interesting compromises between faceting